So, ladies and gentlemen, I want to use this time to welcome all of you to this class. Today, we want to look at one of the tests that we started with. We looked at one sample hypothesis test. Today, we want to look at two sample hypothesis. And we don't want to look at a parametric test, a t-test. We want to look at a non-parametric test, which we are calling the Wilcoxon rank sum test. Or sometimes it's known as the Wilcoxon Mann-Whitney U test. Okay, you have the Mann-Whitney U test, and that is what we're looking at. It's a non-parametric test and a test of samples that are independent. If you look at its parametric equivalent, it's a t-test, independent sample. We will use the same steps in hypothesis testing to examine this. Now, what is the difference between this test and that of the independent t-test? Well, we know that all the tests that are TTTF, they are parametric. The data is parametric, which means that the data is usually normally distributed. Mann-Whitney is, most non-parametric tests are not normally distributed. The data is ordinal or rank. So that is a standard assumption. When we are referring to a parametric test, we use mu, Greek symbol mu. Now we're talking about non-parametric tests. We are going to use the median, and we are going to use the symbol m for the median, so that we will know that it is a non-parametric test. So we'll go through the steps in hypothesis testing, and we'll use that to understand. Now, these steps in hypothesis testing are some things you already know. We will also use a table to appreciate how the test also works. So, what are the steps in hypothesis? Well, I will just remind you, and I know you know it already. The steps in hypothesis testing are as follows. And like I indicated, this is something that you are all aware. The steps in hypothesis testing. Step one has to do with formulate the null and the alternative hypothesis. If you don't understand anything, just type it. Formulate the null hypothesis and then the alternative hypothesis. That was step one. And the last time we learned how to do that. Step two. Step two is to calculate the test statistic. Okay, calculate the test statistic, which we sometimes call the calculated value. Calculate the test statistic and then compare it with a critical value. Compare with a critical value. The critical value is usually the one that you get from the table. Sometimes we call it a tabulated value. Then the third step is to find the p-value. Find the p-value, and then once you found it, you compare it with the alpha, which is the level of significance, And finally, you decide and conclude statistically and practically. That practical conclusion, many don't do. Conclude statistically, and then you also conclude practically. So these are the steps we are going to go through to be able to do Mann-Whitney U test. I'm trying to go slow so that we'll be able to appreciate it. So we're going to understand the hypothesis formulation in Mann-Whitney. I told you that the samples are how many? They are 2. So let's call something like sample A. And sample A refers to, so that's sample A, and that refers to the scores obtained. The scores obtained by students in this course. So these are the scores. Some people had 40%. Some people had 80%. I'm just doing an example before we start anything. Some people had 99%. You can't get 99% in this course. All right, let's assume somebody had it. Okay, somebody had 90%. I'm just trying to make you happy by writing big numbers. Somebody had 55%. So that is a sample, the first sample. Then you have sample B. There's another group like group B. Somebody had 48%. Somebody has 60%. Somebody has 70%. And the last one had 10%. Now you can see that the samples are not the same. So it can be different samples. So the total number of people here are 1, 2, 3, 4, 5. But the total number of people here are 1, 2, 3, 4. So that means that the sample is not balanced. It's an unbalanced sample. Okay. Now, this data must be cleared to be normally distributed. So we want to assume that the data is not normally distributed. Remember, we are making certain assumptions that one, data is skewed. It's not normally distributed. And the variance is also not homogeneous. The variance is not common, or not homogeneous. So non-homogeneous variance. These things are embedded already. Okay. When we say the data is not normally distributed, that means that it is skewed. Non-normal is skewed. So we're going to make an assumption. This one, we're going to calculate the median because the sample is what? Is the data is not normally distributed. We'll not calculate the mean, we calculate the median. We refer to the median as M1. And we also refer to the other median as M2. So how do you formulate a hypothesis? Let's assume that the hypothesis is that the median for group A is at least that of the median for group B. I'm writing the word there. The median for group A is at least that of the median for group B. So the word, the symbolic word in question is at least. How do you formulate a null and alternative hypothesis? Ladies and gentlemen, please watch. I'm going to rewrite it. The first thing you will do in formulating the null and the alternative hypothesis is what I'm just going to show you. The first thing you're going to do is write M1 and leave a space and write M2. And do the same thing below. M1, leave a space, M2. Now the M1 is referring to the median for group 1. M2 is for median for group 2. Then what you do is that you go look out for the key word there. And the key word is at least. And then you ask yourself, what symbol is at least? Who can tell me that? What symbol is at least? This is something that we have already learned. And so you ask yourself, what symbol is at least? And the answer is, well, I got a right answer. Greater or equal to. That is a correct one. Amanda, you typed it, but you just sent it to me. That's okay. So the symbol is greater or equal to. The symbol for at least is greater or equal to. So you write that one there in the middle, greater or equal to. Then you ask yourself, what is the opposite of that? The opposite is what? Less than. Then you bring a colon in front of each one of them. The one with some level of equality, which in this case is the first one, is the null hypothesis. The one without some level of equality is the alternative hypothesis. Okay, so you have the null, and then you have the alternative hypothesis. That is how you formulate. That's how you formulate. So the principle is the same thing, just that the medians in this case are 2. So we are going to take a story, and then with that story, we are going to learn how to formulate a hypothesis. And then we'll go through these steps, the 4 steps in hypothesis testing. Okay. The 4 steps in hypothesis testing. Here, we are going to use that principle to go through all the steps in hypothesis testing. All right. So, how do we begin? The first thing we want to do, okay, is to go and take an example and look at it. So I'm going to show you this example, which you have already in the slides. All of these are examples which you can look at. I don't want to bother you so much with them, but look. If you look at this statement here, write the null and the alternative hypothesis. Okay, if you look at it there, what is the symbol that we are going to use in our gap between the 2 medians? What is a symbol? It's a simple word here. And what is a symbol for? The symbol for larger than. What symbol is that? Greater than. Perfect. Amanda, you are sending me the answer to me personally, but it appears you are not sending it to the group. So the symbol is greater than, and that is a symbol that would define this whole thing. I just want to jump that. Okay. So just go and learn how to formulate this. So I'm going to give you this storyline, and we are going to use this storyline to. I'll be asking you some few things. Kolebu Teaching Hospital is undertaking a clinical trial designed to investigate the effectiveness of a new drug to reduce symptoms of asthma in children. Participants are asked to record a number of episodes of shortness of breath, and this is known as dyspnea. And they are to do that record over a period of 1 week following receipt of the assigned treatment. So these people are assigned the treatment of a new drug, then we record their asthmatic situation, the number of episodes of asthma that they are undergoing. The data is going to be below. I'm going to show you the data, and this data is a non-normally distributed data. The moment you see non-normally distributed data, it tells you that the test you're going to use is a non-parametric test. Okay, so it's a non-normally distributed data. Sometimes you'll be told that the data is skewed or the data is not normal. Then you know it's the same thing. Question is there a difference in the number of episodes of shortness of breath over the 1 week period in participants receiving the new drug as compared to those receiving the placebo? In short, we want to understand whether that new drug was even effective at all. Is there a difference in terms of the number of episodes of shortness of breath? In fact, it's this statement that helps you to formulate the null and the alternative hypothesis. It is from here that you will know the symbolic word, the mathematical symbol to use to be able to do the formulation. But before that, that's the data. The data is indicating that there are 5 people who took the placebo. Oh, by the way, what is a placebo? A placebo is that kind of an injection or a drug or anything actually that is given to a patient, and it is psychologically used to make the person think that the person is taking the actual, phenomenon, so that it gives that person some cathartic ventilation effect, if it does. We use that in a clinical trials to help people to feel that they are taking the actual drug. So a typical example is if a patient has been taking a paracetamol too much, and then doctors have made something with water, but then they call it paracetamol for those who think they are taking paracetamol, but they don't want to give them paracetamol for them to think that they are always taking paracetamol. And so anytime these people are becoming addicted to the paracetamol, they come to the hospital, then the doctors will give them the water pill, which looks like just the paracetamol. And then they'll give it to them. They will think that they are taking paracetamol, but in reality, it's nothing. It's not supposed to have an effect on them. It's supposed to control anything that they think they're doing. So that is, and it's not just a pill, it can be an injection, it can be, in fact, even the stethoscope, if you go to a hospital, okay, the stethoscope, the aura of professionalism beseeching the medical doctor. You see, the medical doctor is that kind of a person whom, when a patient sees, the patient's sicknesses are more or less over. Once you see the doctor, you feel that your sicknesses are done deal, because that person is wearing a white overall, with a stethoscope around his neck. That whole aura is said to have a cathartic ventilation effect on the patient. It's just like the psychic paraphernalia in the voodoo shrine. Those Africans who are quite good at, visiting the voodoo shrine, they believe so strongly that once I go to that place, that voodoo person is going to kill my enemy for me. So the area has to be very scary. So that by the time you get to the shrine, you can be sure that this man has got the supernatural powers. But imagine you get to the voodoo shrine, all you see is research methods books, economics textbooks, okay? You see things like quantitative analysis. Really? Are you going to even think that this person is powerful enough to, effect any voodoo magical powers on your enemy? No. So it's just like that. So that alone is said to have a catharsis on you. Okay? So anything that can have a catharsis, can have a cathartic ventilation psychological impact on the person, is like a placebo. So this is placebo. So those who took the placebo, these are the number of episodes of shortness of breath that they had. So the first person had 7 episodes of shortness of breath after taking the placebo. The next person had 5 episodes. Now remember, the smaller the number of episodes you get, then it means that you are getting solution against your asthmatic attack or your dyspnea. So the number of episodes of shortness of breath, if they are bigger, then there's a problem. It means that a placebo is not affecting you. If they are smaller, it means that they are affecting you. And when you compare those that took the new drug, you can see that whilst the first guy had 7 episodes for the placebo guy, the new drug, when the first guy took the new drug, the number of episodes was shorter. In the second case, the placebo guy won. The number of episodes was shorter. Okay. But then in the second case for the new drug, that person had a higher episode of asthmatic attack. Now, if you look at the last 2 guys, the number of episodes of shortness of breath was lower for the new drug guys than for those that took the placebo. So it kind of appears to show that those that are taking the new drug seem to be doing well. The new drug seems to be helping them to ward off, dyspnea. But of course, this is just a conjecture. So we need to subject everything to a statistical analysis, a statistical torture. And so usually the first thing we'll do, knowing very well the data is non-normally distributed, is by checking if the data is normally distributed. So in research, you do normality test and then check whether the data is skewed. And you can do that normality test anytime, anywhere. But for now, I'm going to use this data and I'm going to work with you how we will now analyze the data. So look at the data here. And the first thing we want to do is to formulate the steps in hypothesis testing. So what symbolic mathematical symbol will drive the hypothesis? Using the storyline here, how do we formulate the hypothesis? How do we formulate the hypothesis? Who can tell me the symbol that would drive the hypothesis testing? Who can tell me the symbol that would drive the hypothesis testing? Let me see. Exactly. Aisha says equal to and not equal to. And that comes from the word difference. Okay. The word difference. Is there a difference in the number of shortness of breath? What symbol is difference? Not equal to. What is the opposite of that? Equal to. So now let's use that principle to write our null and alternative hypothesis. So we will say that you write M1 and then M2 and follow the pattern of M1 and then M2. And the symbol is not different. Difference is not equal to. So you put that there and then you have opposite to be equal to. Then you bring a colon in front of each one. The one that has some level of equality, let me change it. You have equal to and then not equal to. The one that has some level of equality is the down one. And so that will become the null hypothesis. Okay. And then the top one will become the alternative hypothesis. So you've been able to formulate a hypothesis in this sentence. But what does it mean? Well, what this one simply means that the medians of the two groups, okay, the median between, so the median, the medians between the placebo group the median between the placebo group and the new drug group are the same. The medians are the same. But what does that mean in principle? Now, what this means in principle is that there is no what this means in principles is that if the median, the number of episodes of shortness of breath for the placebo group and the number of episodes of shortness of breath for the new drug group, if the median number of episodes are the same, then what it means in principle is that the new drug is not effective. Okay, what it means is that the new drug is not effective enough, because if it was effective enough, then there shouldn't be any difference, there should not be equality. There should not be equality. But if it is effective, if the new drug is effective, then there must be a big difference. Okay, so you got to understand what this means in principle. So this simply means that the new drug is bogus. Okay? I just want to write that for you to know that it's not a matter of just writing the hypothesis, but it's a matter of understanding what you are writing. The new drug is bogus. Why is it bogus? Well, you are telling me that the median number of episodes must be wide enough, must be different from each other, so that the difference will be as a result of the new drug you introduce. Now, the null hypothesis is saying that they are the same. If they are the same, then the new drug is bogus. Okay. But then if you look at this alternative, which is at the top, the last time I told you that which one comes first doesn't matter. If you look at the alternative, it shows that there is a difference. There is a difference between the new drug and, the number of episodes, the median number of episodes for those taking placebo with those taking the new drug. So what this one will imply is that, okay, new drug is what? Is effective, okay? New drug is effective because there is a difference. So you need to understand in simple, real life situation what the null and alternative hypothesis mean. So please keep this in mind, that the null hypothesis is saying that the new drug is useless. The alternative hypothesis is saying that the new drug is not useless. It is effective. It is effective. Now, the next thing you need to ask yourself is this a one-tailed testing or is it two-tailed testing? Who can tell us? Who can type it in? Is this one-tailed or two-tailed testing? One-tailed, excellent. The answer is two-tailed. Many of you are writing two-tailed. So this is a two-tailed testing that we are having right here. Now, two-tailed testing, that's what we are having now. The question we need to ask ourselves is that, so normally when you identify that it's a two-tailed, just put it down somewhere so that you don't miss it. So you write two-tailed, because you come and use that later. We are done with the steps in hypothesis testing. Now, let's go back to the storyline. Another thing you want to identify is that you should always be expecting to be given the level of significance, And I told you the other day that if the level of significance is not given, then you should assume that the level of significance is how many percent? If the level of significance is not given, you should assume that is how many percent? Type it there. Excellent. Amanda, that is 5%. It means that the level of significance is 5%. So once again, in this context, we want you to understand that the level of significance here is 5%. And so you also want to document that and put it down, that the level of significance is 5%, so that at least, okay, you don't forget. Okay, so you write alpha is equal to 0.05. Okay, now you've been able to set up yourself with step one. Let's go to step two. And step two, in case you forgot, let me just remind you of step two. Step two is calculate the test statistic and then compare it with a critical value. So that's what we are going to do. We're going to calculate the test. Somebody says, what if you are given a confidence level? You will never be given. Okay, because, by the way, the confidence level, okay, 1 minus the confidence level is the alpha. Okay. So if you are given 99% confidence, okay, then you know that the level of significance is 1%. If you are given 95% confidence, then you know that the alpha is 5%. Okay. But most of the time you have these p-values. All right. So let's try and calculate the test statistic. And that is what takes our time. That principle is what can take our time. So let's see how we can do that, the test statistic. How do you do that? Well, in order to do the test statistic, you need to put this thing in a very beautiful perspective. Okay. We're going to now do something, and that something is create a table. So the first step is to document your numbers. So I'm going to document my numbers. The first one is placebo group. Let's call it P. Then you have the new drug group. Let's call it ND for the new drug. We're going to write the numbers again. Then you have another column you should call the rank. Okay, so you're going to have rank for the placebo group and then rank for the new drug group. And then you underline each one of them very nicely. So you're going to write these numbers and then you put them down. Now I'm going to copy these things just as we have in the slides so that at least you know where we are coming from. So I'm just going to copy these things and nicely. So remember, but when you are going to write these things there, which I'm going to do, when you are going to write them there, you got to write them in such a way that you order them in order of ascending, in an ascending order. So I'm going to now pick these things and then write them in the new page I'm going to create, but in an ascending order. So when you look at this group, the first number that comes in an ascending order, we are climbing. The first number I'll have to put down is what number? What number do I have to put down first? Okay. What number do I have to put down second? What number do I have to put down third? Okay. And once you are writing these numbers, you should know which group they belong to. So who can type in there the first number that I have to write? Okay. So this is like you're putting all of them together. You're shuffling all of them together without respect to whether it's a placebo number or it's a new drug number. Just lump it all together and tell me which number comes first. Which number comes second? Okay. All right, I'm getting several answers. So most of you are saying 1 comes first. So now that is correct. So we go to our table and this is what we do. 1 comes first, and that 1 is in which group? You have to remember the group it is in. And in this case, it's in the new drug. So you write number 1 for the new drug. The second number that comes is number 2. You've got to be going downward like that. Okay, number 2. Then the third number that comes is what? Is number 3. You can see that. Okay. Then the next number that comes after 3 is what? You can tell me. The next number that comes after 3 is what? And remember, you should put them in their respective groups. Okay. So the third number is number 3, which is also in the new drug. Now, what about the next number? Is number 4, but that belongs to both groups. Okay. Look at number 4. You have number 4 in the placebo, and you have number 5. So we call it a pair. There is a pair. There is a match. Okay. So in those, when you are writing, you will say both. Both. So the next number, which is number 4, appears in both. And when you are writing it, this is how you write them. You write 1 here for the placebo, and you write another 1 here for the new drug. And then you keep going. You keep going. The next one that comes after 4 is what number? It's 1 number. And which group is that? The next number that comes after 4 is what number? And which group is that? Okay. Which group? Excellent. Okay, excellent. Aisha, you're doing well. Okay, so it is number 5. And so that number 5 is in placebo. So you put it under placebo. The next number that comes after 5 is what? 6. And it's in which group? Excellent. Jerry Lawson. Okay. The answer is 6, and that is in both. So you put that down. The next number that comes after 6 is one number, 7. That is in which group? Placebo. The next number that comes after 7 is what number? Okay. Aisha, that is correct. Okay. Benjamin, that is also perfectly excellent. So you now have number 7, which is in which group? Placebo. And then you have number 8. Sorry, after number 7, the next one is 12. Okay, and that is in placebo. So you can see clearly that we have been able to order everything. And always remember that you have the sample size in each case. You can see that the sample size is still 5 here, and the sample size is also 5 in the new drug group. So what you just did, the first step is order the variables in an ascending situation. Okay. Arrange the numbers in an ascending order. not forgetting the groups they belong to. Arrange the numbers in an ascending order, not forgetting the groups they belong to. Arrange, I'm saying this thing so that you can at least put it down in your somewhere. Arrange the numbers in an ascending order and don't forget the groups they belong to. Now, once you are done, the next one, which is usually a bit complex one, and the most important one, and the last thing actually, is to rank the numbers. Rank the numbers. So we are going to now look at each number and rank them. And let me just give you a bit of an idea about ranking. When the time you are ranking, you have numbers like first, numbers like second, okay, numbers like third, numbers like fourth, okay. Now, but I will not be using those first, second, the third, the fourth, because it might, so instead of first, we'll say number one. Instead of second, we'll say number two. Instead of third, we'll say number three. Instead of four, we say number four. But those numbers should not be confused with the actual numbers that we have here, okay? Because these numbers could have been in tens and hundreds, okay? So please note. Now, if I am ranking, the first number will be number one. I'm going to give you a quick way of ranking. I'm going to give you something like A, okay, and then B here. Just give you some quick numbers. The first number I'm going to give you is 5, and here too is 5. The next one I'm going to give you is 8. Here too is 8. Here too is 8. Here too is 8. The next one I'm going to give you is 12. Okay, and here is 13. Okay, and the last one I'm going to give you is 14, 14, and then 14 on this left side. Okay, so I'm going to use this one to do some ranking, and then I want you to follow me, because that way you can appreciate the ranking we are going to do in this one. So I'll do rank for A here, and then rank for B here. Okay. Now I've done them in an ascending order already, so there's no need to do it in an ascending order. So the first number one will be for both of them, isn't it? Number one will be for, because if you are to rank them, this one will be number one for the 5 and number one for the other 5. Now, when there's a tie in ranking, when there's a tie, what you do is that you add the ranks together and take the average. Okay. I want to put that point down because it's very important. Okay. During a tie, okay, you don't add the numbers together. Add the ranks, okay, the numerical ranks together. Add the ranks, is the ranks you are adding together, and find the average. Find the average or the mean of the rank. Okay, so let's go back to where we were before. So you can see that you can see that in this context, number one should have been 5, and this one would have been number 2, but there's a tie. There's a tie. So you have to give this one number 1 and give this one number 2, but you don't give it to them. You add the ranks. So you do 1 plus 2. That's how you're going to do it. You're going to do 1 plus 2 and then take the average. 1 plus 2 is 3. The average is 1.5. Okay. So you will now give the rank 1.5 to the first guy and then 1.5 to the next guy. So we in our mind, we'll write 1, in our mind, we'll write 2 for this, but then we'll have to add the 2 ranks together and find the average and share the average for each one of them. So this one will be given a rank of 1.5, this one will be given a rank of 1.5. But don't forget where you ended. You ended at rank what? 2. So continue. This will be given a rank of what? 3. So the 8th here will be given a rank of 3. But rank 3, there's a tie. The moment you get to the rank, there's a tie. So don't forget, the moment there's a tie, you are going to still have the rank numbers, but you'll find the average of the rank. So this would have been given a rank of 3, a rank of 4, a rank of 5, a rank of 6. But they are all ties. They are all 8, 8, 8, 8. So I'm going to now add these ranks together. 3 plus 4 plus 5 plus 6. Okay. And when you do that, that gives you what? 18. 18. Divide the 18 by the 4. You're finding the average. 18 divided by 4. Okay. Now, at this stage, this is where sometimes you trust your head. If you trust your head, do it. If you don't trust your head, take a calculator. And that will give you 4.5. 4.5. So it means that you are going to give this guy 4.5, this guy 4.5, this guy 1.5, this person 4.5. You have shared the rank for all of them because there's a tie. But don't forget where you ended. You ended at rank 6. Okay. So the next rank is what? 7. So that one, there is no tie. So you give it 7. You are done with that. Okay. The next one is what? 8. That one too, there's no tie. So you just give 8 to it. The next one is 9, but there's a tie. There's a tie for 14. Okay. So now, you now do 9 plus what? 10 plus what? 11. So you now do rank 9, rank 10 plus 11. And then you find the average and share it for all of them. So 9 plus 10 is 19. Okay. So you take a calculator, you do 19 plus 11, that will give you 30. 30 divided by 3, that will be 10. Okay. So don't forget these ranks. The ranks here were 7, and the ranks here were 8. And now this 9, 10, and 11 gave us what? 10. Rank of 10. So you share this 10, this 10, this 10. Don't forget where they are belonging to. And that is how you do the ranking. All right. So we've been able to just give you a simple example, and then I've ranked these numbers using the principle of ranking. The most important thing is that when there's a tie, like here, 3, 4, and always don't forget where you ended because you continue from there. I'm going to use that same principle. Okay, then you walk me through how I'm going to do this ranking. It's very simple. So the first rank will be number 1, and that will be for which group? Somebody should write it there for me. The first rank will be number 1. That will be for which group? Don't forget the group it belongs to. New drag. Excellent, Marcus. Okay, so you now write 1. Okay, let me just clarify these things well. 1, and that group is. The next rank is 2. That will be for which group? New drag as well. The next rank will be 3. That will be for which group? New drag as well. The next rank is what? And which group is that? Okay, let me see. The next rank will be both, exactly. So it will be 4 for both. But it's not going to be 4, it's going to be 4 and 5. Okay, okay. So it's going to be 4 and 5. So you now 5, 4, and 5, you add them together. You find the average, and that'll give you what? 4.5. So here, okay, the first one here will be 4.5. And then this one here will also be 4.5. Okay. But don't forget you ended at 5. So the next rank is what? 6. And that'll be for this number 5. So the next rank is 6. Then the next rank will be 7. But the 7, there's a tie. Number 6 and number 6 has 7. So there's a tie. So it will be 7 and 8. And so you have to now find the average. 7 plus 8. 7 plus 8 is 15 divided by 2. So that will be 7.5, 7.5. But don't forget you ended at 8 here. So the next rank is what? 9. And that is for the placebo group. So you write 9. And the final rank is 10. That is for number 12. So you write 10, which also belongs to the placebo group. Okay. Excellent, excellent. Jerry, Amanda, Aisha, you guys are doing perfectly fine. And that is how it's got to be. So, ladies and gentlemen, at this stage, you've been able to do ranking and allocated the ranks for each of them. This is the most difficult part. But once you've been able to crack it, you will do well. All right, so we've been able to do the ranking. The next thing that we are going to do is to apply certain beautiful principles to do. And there are certain commandments. There are certain commandments that you want to always have in mind. The next thing you want to do is to add the ranks together. Okay. The total rank for the placebo group, call it rank 1, R1. The total rank for the new group, the new drug, you add that and then you total it. So who can tell me the total for that? So these totals, well, let's get some names for them. Okay, let's get some names for the totals. So the first one should be R1. That's the total rank for the placebo group. R2, that's the total rank for the new group. Okay. Now let's go to the, and then you tell me the total. Add them and let me know the total and type the answer there. What is the total rank? What is the total? What is the total? Total rank for the placebo group is going to be, I just want one answer because that will help me to know that you are with me. Okay. The first guy to crack it is Aisha, and that's perfect. 37. And then the next one is 18. 18. Okay. So you write so you have 37 for the placebo group, 18 for the new drug. These are R1 and then R2. Now, in order to know that you are on the right path in this question, you do something we call the first commandment. And the first commandment is a certain formula that you got to check. So this is a way to check whether you are on the right. You always check this to prove whether you're on the right track. I'm going to show you this commandment. Commandment is a very, very simple but beautiful commandment. This is what it says. It says that the summation of the ranks, R1 and then R2, the summation of the ranks, R1 and R2, should be equal to, and this is important because this commandment is very, very important. It should be equal to n into bracket n plus 1 over 2. N outside n plus 1 over 2. Now the rule says that anytime you check this and they are equal, you are good to go. You can actually smile at your enemy and move ahead. So let's look out for the total rank for R1. R1 plus R2, 37 plus 18. That's what you're going to do. So this is going to be 37 plus 18. Okay. 37 plus 18 is 55. Excellent. I like the answers many of you are giving. Jerry. Okay. So you get 55. Then what about this? This will indicate the total number. So N is the total sample size, all of them. The total sample. And the total sample is 10. So this will be 10 into bracket 10 plus 1. Now, how do you know the total sample? Just go to your table. And in fact, when you go to your table here, you will know. You count them 1, 2, 3, 4, 5, 6, 7, 12. So the total sample is 10. So that is how you substitute there. And then you multiply 10 by 10, which is 10 by 10 plus 10. So that is 100 plus 10, which is 110 divided by 2, 55. So both of them will give you what? 55, equal to 55. Once this is established, you are good to go. Your commandment number 1 is passed. And so you can now go ahead and calculate the test statistic. The test statistic is a formula in both cases. So let me just give you the test statistic. The test statistic is called U statistic. And because there are two groupings, we do 2 different U's and select one. So I'm going to calculate the U statistic for the first one, okay, and the U statistic for the second one. How do you calculate it? It's very simple. It says that take the first rank. Okay. Once you take the first rank, you subtract the following from it. N1 into bracket N1 plus 1 divided by 2. It's a very simple thing. Okay. This second one will also be R2 minus N2. By now you should know what N is. N2 plus 1 all divided by 2. Now, N1 is the sample size in the first group. That's N1. Is the sample size in the first group. And N2 is the sample size in the second group. So let me try and do the first one here with you. It's just substitution. So I'm going to do this one right here in front of you. So this one. And then I'll do the second one. So this one says R1. One is 37. So you write your 37 minus N1. Go and check the first group. The sample size there was what? Who can tell me? The sample size in the first group, what was that? The sample size. Excellent. That's 5. Okay. That means that you are following Aisha and Jerry. Okay. So that's 5. So it's going to be 5 into bracket 5 plus 1 over 2. Okay. Now 5 plus 1 is 6. So 5 times 6 is 30. 30 divided by 2 is 15. So 37 minus 15. Okay. That is 37 minus 15. What would that be? That would be 22. So the answer to this will be 22. Then we go to the next one. The next one is R2. Check the value of R2. That is 18. So you now put in the 18 minus the same thing. Remember, this one is also 5. So it's 5 into bracket 5 plus 1 over 2. So that will be 18. And then we are talking about 18 minus the same value, 15. 18 minus 15. I like when people write the answers ahead. It means that you are working with me. It is 18 minus 15. That will give you the value of 3. So our U Mann-Whitney U statistic 1 is 22. And the U statistic 2 is 3. Which do you select? Because one of them is what you need. Always you select the smaller U. That is a rule. The smaller U. Okay, smaller U. Smaller U is the right one to choose. The smaller U statistic. Okay, so we can now conclude, but before you conclude, you have to do your second commandment to be sure that you are on the right. That second commandment is a very important commandment. For you to know that you're on the right track, do this final check. So check this. This one is just a check. And the check says that your U1 plus your U2 must always be equal to the N1 times the N2. The U1 plus U2 must always be equal to the N1 times the N2. If they are equal, congratulations. You can. Now, our U1 is 37. Our U2 is 18. Our N1 is 5. Multiplied by another 5. When you check it carefully, are they not equal? Both of them will give you a value of what? Oh, sorry. Let me just make some pictures. It's not 37. Okay. We had 22 and 3. 22 and 3. So our U1 is 22. Our U2 is 3. So this will give you 25. And this will also give you 25. Congratulations. Once you've done this, you know that your check is perfect. And so our U statistic, okay, our U Mann-Whitney U test statistic. This time you're not going to call it U1 or U2 because you've selected a 3 already. That is there. Our Mann-Whitney U statistic is equal to 3. This is the test statistic. Well computed, well executed, and now you are done. This is a calculated value. And the rule says, step 2 says that compare that with the critical value. What is that critical value? Well, the critical value is an important thing, and it is some very beautiful formula. Okay, that's your. What is the critical value? The critical value is saying that U subscript N1, subscript N2, and then alpha. So you find that value. Okay, this is a critical value. So U subscript N1, subscript N2. Now, what is that? Well, it's a critical value, which means that we have to find it on the table. So that means that there should be some Mann-Whitney U table. Okay, there should be some Mann-Whitney U table. But that means that you need to understand what is written here. So if you are to equate this, it's simple. It means that you should find N1, N2, alpha. Now, what is N1? It's 5. What is N2? It's also 5. What is alpha? Who can tell me the value of alpha? Who can tell me the value of alpha? Who can type it there? Let me see. 5%, Marcus Terry. Excellent. So that is it. So now you have a value of what? 0.05. So now you have 0.05. So we are going to read this on the table. So that means there must be a special table for this. Yeah, there is. So let's go get a special table that does all of these things. So this is your Mann-Whitney U table. Okay. This is your Mann-Whitney U table. Now, I need to give you a bit of an idea about this table. Okay. There's a two-tail testing at the table at the top there. Look at it. Two-tail testing. And then when you scroll down, there is another one, which is one-tail testing. You can see it here. So this is one tail. Okay. And then the one I showed you before is two-tail. Okay. Now you will have to identify which tail you are dealing with and then go for that table. Do you remember which tail we are dealing with? You can type it there. Which tail we are dealing with? Is it one tail or two tail? One tail or two tail? All is one. Excellent. All right. Two tail. So now that we know it's two tail, we are going to deal with this two tail. Now, the top values are the N1. The far left values are the N2. N2. So the N1, you know your value of N1, you select it at the top. Okay. The top values are the N1. So here, these are the values you'll be seeing. You select the degrees of freedom that you have identified. Okay. So that is a degrees of freedom for N1 degrees of freedom. So the value we had was 5. So that is this number. You select the 5. You select the 5. And then the N2 was also what? 5. So that one too, you select the 5. And then where they meet, this is 5. Okay. And then the N1 is 5. So where they meet is this number. So they meet at this number 2. Okay. They meet at 2 and then 0. These two numbers. 2 and 0. I'm sure you guys can see. Okay. 2 and 0. Now that you know that they meet at 2 and 0, the question becomes, okay, which one do you select? 2 and 0. Well, the simple thing is that one of them has a 1%, 0.01, and one of them has a 5%, 0.05. So which of these two will be your tabulated, Mann-Whitney U tabulated? Who gets? Which of them? 2. Excellent. Benjamin, Amanda, these are excellent answers. So our value is going to be 2. 2. And so you go back to your analysis, okay, and then we can now put it down and say that the final value for our U statistic, Okay, the final value for our U statistic is equal to what? 2. Sorry, for the U tabulated, or the critical U, the critical value for the U is 2. Remember our statistic, the calculated was 3 on the left here. And now our tabulated is 2. So we are ready to compare the two answers and ready to conclude. Okay. Now, you need a decision to do that. Anytime you are doing this, you need a decision. So let me give you the decision rule. The decision rule is a very simple decision. The decision rule is this. Okay. And you know, we have a decision rule for the parametric, the T statistic, okay, which says that one says if the calculated is greater than the tabulated, you reject the null hypothesis. Do you remember? It's the opposite here. That one was parametric, so this is non-parametric. So here, if the calculated is less than or equal to the tabulated, you reject the null hypothesis. You reject the null hypothesis. Our calculated here was U equal to 3. Our tabulated here was U subscript 5, 0.05. Okay. And this tabulated was equal to 2. So given this scenario, should we reject the null hypothesis or we don't reject the null hypothesis? Who can tell? Okay. Is it reject or don't? Type it that for me. Is it reject or don't? Reject or don't reject? Okay. It is don't reject, and I'm getting some powerful answers of don't reject. Okay, so looking at this, we can say don't reject the null hypothesis because our U calculated, our test statistic, our Mann-Whitney U statistic is not less than the U critical. And so we conclude that don't reject, okay? We conclude that don't reject the null hypothesis. That's our decision. But what is a practical conclusion now? Well, to be able to get a practical conclusion, go to your hypothesis, okay, so that you can conclude intelligently. The null hypothesis said, and this is here, the null hypothesis says the medians between the placebo group and the new group are the same, and so the new drug is bogus. That is a null hypothesis. And we are saying, based on all this statistical analysis, don't reject this null hypothesis. So what will be our conclusion? Our practical managerial advisory conclusion. What will be that? What will be that? In terms of the new drug, what are we going to say? In terms of the new drug, I really want somebody to tell. The new drug is what? Is ineffective. That's it. So we are not rejecting the null hypothesis. So we are concluding that the new drug is bogus, as we have already said. Okay, we are not rejecting it, and so it stands that the new drug is bogus. Okay, so we've been able to prove beyond statistical doubt that a new drug is not good after all. However, ladies and gentlemen, I want you to think about something. This is where intelligence comes to play. You see, the new drug is not good. Does not mean necessarily that may be the case. So let's check some few things. Okay, I want to. Now, how could it? Because see, if you can remember the analysis, if you look at it carefully, it appeared that the new drug was leading to a lot of lower number of episodes of shortness of breath, isn't it? Compared to the placebo, it appears so. It appears that the new drug was really reducing the dyspnea. So why do you say it is not that effective? And the simple answer is because the sample size is too small. The sample size is too small. Now, if you look at this, the sample size is just 5 for the new drug, 5 for the placebo. In fact, all of them is just 10. For a sample size to be big, at least it should be 30 or more. And here you just collected some small information from 10 people, and you want to use that as a test trial. Okay. So in a computer analysis, I decided to increase the sample size in both cases. I increased the number of the new drug to 30, and the people that took the new drug to 30, and I increased that of the placebo to also 33. And what I found is that, no, the new drug is effective. So in this context, and of course, I couldn't give you 30, because if I give you 30, we are going to do a lot of calculations. So this hand computation is supposed to be easy and simple. So the new drug is ineffective because the sample size is small. Okay. So sometimes when you want to determine whether the sample size, everything, by the way, is in your slide. If you want to determine whether the sample size is large, if you want to conclude that things are really as it is, increase the sample size. Okay. So what if the new drug, so now the new drug is not effective, so there's no difference. That's what you're going to say. There's no difference in the number of episodes of bread for the new drug. But that difference, may not necessarily work. Our example is unique. On the surface, the data suggests a difference, but the sample size are too small to conclude that there is a difference. You will learn the skills of using the R software to calculate this in the practical section. And this is how you do Mann-Whitney U test. I have a couple of examples here. This is another example. A random sample of starting monthly salaries of graduates from 2 Ghanaian universities, UG and then PNUST. Now, if you look at the numbers, just the same thing. The question is this: is there enough evidence at the 5% level to say that the median starting salary for the UG graduate is higher than the median starting salary for the KNU graduates? Solved by hand and the software. Now, if you look at this, are there some pairs? If you don't take it, you might think there are no pairs, but there are. For example, number 32 and number 32, these are pairs. Number 32 and 32, they are pairs. So sometimes you just have to open your eyes and identify number 29 and number 29, they are pairs. So try your hands on this, and you will notice that, this is how it's got to be. Ladies and gentlemen, that brings us to the end